Hey guys, today I'm going to be bringing you um, the Titanic Machine Learning Challenge on kaggle. This is a great, um, basically, data set to look at for beginners and if you're new to machine learning because it's a lot of just data cleaning and then essentially just inputting it into a model. And so I'm basically going to walk you through um, how I would go about this problem if I was attempting it for the first time. So I've already got my data set up already. And so basically we're going to be using a lot of pandas just to manipulate the data set and clean it up. But let's get started. So basically your first order of business is you want to see if any of the values are NA because those are basically going to have an error in your model, and so we're going to have to account for these. So we see that there's age and cabin and embark. There's some NA values, and so basically to account for this, we're going to look at the medium of age. And so what that does is we basically see that the median for the training set, the median age is 28. So we want to fill in all those NA values with the medians. So we can do that by doing train. We can just do an in place. Dot fill NA. It's a great command. And then median. And then in place equals true. So if we do that, we rerun this again, you'll basically see that we now have 0 NA values for age. So that's sweet. So now we also have to do this for the test cell. So let me just copy and paste and change this. I might just set up a data frame. So I'm doing this because I can just write a for loop to iterate through. Yeah, it takes longer, but there's not that much data in this set, so it shouldn't be an issue. Ooh, one sec. I almost filled in the testing set with the median from the training set, so that would have been bad. Median train is sweet. So now we probably want to take care of the cabin that they're in, so we can basically call the cabin, and then we were going to do our value count here. So this is essentially going to print out all the values, and we see that for the most part it's going to be a letter associated with a number on the end. And so let's assume that the letters are basically all around the same area and same fare price. We could do a more in-depth, but I think it would be safe to assume that. And so we can basically, and also if you don't have a cabin, honestly, we just kind of want to we want to fill that in with 0. So um, so if you don't have a cabin, we're basically filling in the testing and train data set right now. If you don't have a cabin, we're filling in a 0 there. So now we're going to have 0 here if we run this again. But basically, let's just grab the first letter because I feel like that's going to be the most important. So if we want to do that, we can basically create an empty array, so cabins. And then for I in train cabin, cabins.append string I. So what that's going to do is it's going to append all these cabins to this empty array. And then we can run that again for so what this code is, if we look at letters, we basically see that we've grabbed all of the first letter from every single column. So we have a 0, and then it's going to be C, then it's going to be 0, C, 0, 0. So you're going to see a lot of zeros because remember we saw that we had 687 empty columns. So we basically have just grabbed the first letter and appended it as a string. So, and then we can basically just now the train column is all basically first letters, but we're going to want to do that for our testing data frame too. So let's just copy and paste because that's the fastest way to go about it, and then we can just change this to test. Copy, test. And then so now if we look at our train head, we see that our cabin is either a 0 or the first number. So that's sweet. That's going to definitely help out our algorithm when we're putting it into a model. So let's see what else we have to do. So we see some NA values embarked. So we kind of want to take a look at that because that's going to pose an issue. So we can once again run value underscore counts all the data frames, counts all the values in the specific column of the data frame. And we see that S is the greatest. So just to keep our data rather consistent, I think we're going to fill in the empty values with our mode. So we can do train embarked dot fill NA, and then S, our value, and then in place equals true. So basically what in place does is it just does that to the data frame at the moment. So if you do it without in place, it's basically going to print out the data frame, but it's not going to actually keep that command you've issued it. It's going to erase it once you move on. So we want to keep that. So if we do that, we're going to see that we don't have any missing values if we go up here. Sweet. And so remember, we also have to do this to test that data set. So test embarked dot fill NA S in place equals true. Let me go up here and just whoops. So, okay, we see a fair value is missing on the test set, but not on the train set. So you always want to test the, check out the test set as well as the train. So let's investigate this further because that's going to pose an issue. So we might as well, there's no fair value. We want to fill that with median because it looks like it just got left out. So we can just do test classifier dot um, and then we also have to do it in place. So that should have cleaned this up. Sweet. So now we have no missing values. So we can basically go on with our analysis and prepare the data for a model. So the first order of business is always clean up the data, fix all the missing values. That's the most important. We can also kind of narrow down. We see the data frame. We have a sibling, spouse, and a what is P arch? Number of parents / children aboard the Titanic. We can basically form those into a single column. Family members. I think that's a better measure, and it just gets rid of some dimensionality within our data frame. So we can create a new column. And then we can apply a lambda function to both of those columns. So what a lambda function does is, let me just finish. So the lambda function, what this lambda function is going to do is going to go through each column, our sibling spouse and our parents and our child, and it's going to add them up. So it's going to do 1 plus 0, that's going to be 1 for our family column. 1 plus 0 is going to be 1. So it basically adds each row and adds it onto a new column, which is the train family. And our access is basically referring to our columns. And then we're also going to have to do this for our test. Oh, we need to capitalize. And let's look at the training column again. Family, sweet. So we see that it's adding up these. Maybe if we extend this, it might show a little bit. Yeah, so we see a family of 4. 3 plus 1 equals 4. 0 plus 2 equals 2. So we know that's working. And then since we have the family members, we can get rid of some of the redundant columns. So let's create a column vector or array of columns that we want to drop from the list. So we're going to drop name just because it's a little difficult to deal with. You could essentially look at titles, but that would take some more time and we're not going to work with that today. And then our ticket does not seem to be that important. So basically these are the columns that we want to drop from the data frame just to clean up our data frame. Because remember when we feed the model, when we feed the model data, it wants numeric values. So we're basically going to have to convert to dummies, and some of the data it will just not be applicable. And so to drop these, we do train. Actually, for data frame and data frames, because we have our train and test data frame in the data frames array, data frame dot drop calls axis equals 1 and then in place equals true. So let's look at train just to see if that command worked. Sweet, so we see that it dropped the columns that we wanted it to drop. Okay. we probably have a decent model. We probably have decent data that we can now feed the model, but we see that we have some issues here because we have embarked as a text. If we look at our data types, we see that we have an object. Cabin is an object, and then embarked is an object. So we need to take care of those before. So we can basically, so there's this wonderful library called One Hot Encoder. You can also just use a PD get dummies, but they essentially do the same thing. If we do pd.get dummies on the training data frame, and then look at this, you see that it's basically changed everything. So we have a cabin A, cabin B, cabin C, cabin D, cabin E, cabin F, cabin G, cabin T. So it's basically changed everything into each row is going to have a 1 if it's true. So you have a bunch of zeros and then a 1. So that's super nice. So that allows our model to work with that data. And so we need to do the same thing for the testing data frame. So we see we have a different number of rows and columns. So that's an issue. So we kind of need to inspect where we have those issues. And so I suspect it's going to be in our cabins. So we see that we have a cabin T up here, but we don't have a cabin T down here. Cabin A, cabin B, cabin C, D, E, F, G. So we're just going to drop these because it's probably a very small value. Like there's probably only one passenger that was in that cabin, so it won't impact the data that much. And it's easier to work with. Oh, we didn't specify the axes. So why is that not working? Oh, because we changed it into a test data. So that gets rid of one of the missing columns. What else? Cabin 0, cabin A, cabin B, cabin C, cabin D, cabin E, cabin F, cabin G, cabin T, which we got rid of. Oh, we're looking at whether it survived or not. That's my bad. Okay, so we're actually good to go. We can essentially, our Y is going to be our train data frame, and then whether they survive. So we print Y, we get a bunch of columns, which is good. That's what we want. And then we're going to want to drop that. So train underscore data frame dot drop. So we're dropping this because you want to train it on a Y prediction, and you can't have that Y prediction when you're training it, or it's just going to be like it knows the value beforehand. So the next thing to do is set up our X test and our X train. So these will be our inputs when we're predicting the model. Just take a quick look, make sure everything's good. Sweet. So we have all the same rows. So I've worked on this problem before, and the best model is really a random forest classifier. So it's an ensemble method, and it's really nice. So we're going to use that to predict. So it basically predicts their class. So we just have two classes. It's whether they survived or not. And so it should be relatively accurate. So I'm just looking up the, okay, it's from, and then I'm also going to import grid search CV, which is a little bit more advanced. So it's basically a hypertunes your model so you can find the best parameters to input. So that's going to be a huge help. So we can create our model, random forest classifier, and then we set up a param grid. And so this is for the grid search CV. So essentially what this is that we give it a list of parameters. So we're going to say number of estimators, say let's give it 100. We're not doing it there. Let's give it 100, 200, 500. Set the max features to auto. And then the max depth is how deep we want it to go. So 6, 7, we might change it to 7 and 8. So we don't want to input too many parameters or it's going to take a while to do that model. So essentially it does like 3, because you have 3 values here, times 1 times 2. So that's 6 occurrences it's going to search for. And then let's do our criterion. Test it as Gini and entropy. So CV equals grid search CV. Estimator equals our random forest that we initialized here. And then we give it the param grid. So it equals param grid, and then CV equals 5, which is just the default. And we do CV.fit. Our X train and a Y. So we're basically giving it this data and then whether it survived or not. So we're just training the model right now. So if we run this, might take a little bit. But once this finished running, we can essentially find the best parameters from our model running this command. And so I might actually set up while we wait. Okay, so we want to give it these parameters. So we can do n estimators equals 200, max features equals auto, max depth equals 7, and criterion entropy. Which, so this basically ran through each of these parameters. and figured out the best combination. And then if we run this command, we figure out those parameters. So if we run this, we have now created a good random forest models, but we still need to fit the data on this to train it. So it looks like the model's done predicting or fitting. So we can now predict our Y predictions on the test set. And so if we look at this, these are all the predictions. So it's predicted whether a passenger survived or not. And so we don't, we basically submit this to Kaggle. We have to look at how they want it to be submitted. Let's test that. Do they have an example? Oh, okay. So they want our passenger ID and whether they survived or not. So we have to create a data frame for that. So right now, this is a little bit of an issue. We have to reshape our data into this format to put it into a data frame and then submit. But we also need the passenger ID as our submission. So create a data frame equals pd.dataframe. So that's whether they survived or not. Let's create a new column of passenger ID. Let's just give it. Let's check it out. Okay, so we need to rename. I'm actually going to set our index as passenger ID first. That's a better way to go about it. Just check it out. Sweet. And so now we can essentially, this is whether they survived or not, we can essentially just print this to a CSV and then submit those predictions. So pandas is great for this, 2_CSV. And then you essentially input your file path here, and that will basically put it to a CSV. And so now if we want to submit that CSV, I've just put it directly into my directory that I'm doing on my other monitor. But Let's see. Um, Submit our prediction. Let's see how well our model did. Oh, huh. So, whoops. We need to fix up this column. So that's fun. Okay, we can do that really fast. Columns equals passenger ID, and then survived. And then we can do submission under DataFrame.columns equals I for I in calls. So that's just going to iterate through and add that to the name. Length mismatch. Oh, we don't even need this because that's the index. So if we print this out again, we see that it survived. Sweet, that's what we want. And print that to a CSV again, so you can submit. So this time it should work. Sweet. So we got a score of 78 point. Oh, which isn't actually I improved on my. Oh, not an improvement. Okay, but um, let's see, 0.7870. I say it be somewhere right around in the 2000s, and there's almost 20,000, so that's top 10%. That's a pretty good model. We really didn't change it that much. But yeah, that's all I have for you today. If you liked the video or you thought it was informative, please make sure you like and subscribe. And then if you want to follow my GitHub, I'll post it in the link below where you can see the source code to the model that my best scored model. So thanks for tuning in. Have a good day.